Okay, so in the last section, we learned that 1 mole corresponds to an exact number of particles. So with this in mind, 1 mole of a given representative particle will also have a certain specific mass. So think about it like this. So you have a single penny. If you put it on a balance in the lab, it has a mass of approximately 2.5 grams. If you put a second penny, you would probably find a mass of 5.0 grams. A dozen pennies would have a mass of 2.5 times 12, which is 30 grams. One mole of pennies would also have a very specific mass. That would be 2.5 grams times this number of pennies. And if you actually put it in a calculator, you would find a mass of 1.51 times 10 to the 24th grams, which is a very large mass. If you wanted to count $246 of pennies, you could measure the mass with a balance and count them indirectly. So here's how we would do it. So $246 of pennies, that's really 24,600 pennies. And so here's $246 of pennies. And if I know that 1 penny is 2.5 grams, we could calculate the mass, 61,500 grams, which is 61.5 kilograms. For those of you that don't use the metric or SI system very often, this is 135.3 pounds. So if you measured out 135.3 pounds of pennies, we would say that we indirectly counted $246. We'll use the same relationship between moles and mass, and this is for practical reasons. In our lab, we have a lot of instruments that could easily measure the mass. So Chem 1 typically uses the blue balances, and we have 6 or 8 of those. AP Chemistry typically uses a more advanced balance, and I have 2 of those. And then we have one that is extremely accurate, and we only have 1. So I have a lot of things that can measure mass. I even have some old style balances where you physically have like a teeter-totter where you put on little weights and you see how it balances. But what I don't have is an instrument that can directly count the number of atoms or molecules. We can't do it. They're too small for me to look at them and count them out. If I wanted to count out $1 in pennies, I could physically count 100 pennies. We can't do that with atoms or molecules because they're just too small. The easiest way for us to make measurements is to do it in grams. We're going to measure it on a balance, and then we'll just convert it as needed. So when we measure the mass of a sample, what we are doing is indirectly counting. the number of particles in the sample. Here is a very helpful piece of information. The number of grams of 1 mole of an element is the same number as the atomic mass on the periodic table. So a review on the atomic mass. Remember that this is a weighted average of all the isotopes for that element. In a sample as large as 6.02 times 10 to the 23rd atoms, we can expect the atomic mass to accurately reflect the sample that we're looking at. If you were in our classroom, I would have you look at our periodic table. The mass is the red number on our classroom periodic table. It is in the bottom of each individual box. So the atomic mass number ends up telling us the number of grams in 1 mole of an element. And we have a definition for this. The number of grams in 1 mole of an element is called the molar mass. The unit for the molar mass is grams per mole. And we typically abbreviate this G/MOL, grams per mole. So you should have a periodic table somewhere around in your binder. So get it out now so that we can take a look at it. And we're going to look at some specific elements. So let's say that we want to know the mass of 1 mole of sodium. And so we look at our periodic table and we find sodium, and it has an atomic mass of 22.989707. Let's write that whole thing down. Your periodic table might round differently too. These are averages, 989,707. So here's what we're going to do in this class. In Chemistry 1, we're going to round this number to 3 significant figures. And remember, we start left to right. The first significant figure is 20. The second significant figure is this 2. And the third one would be this 9. But look, there's 8 here. It's going to round up to 9, which rounds up to 2. So we can just say that the molar mass of sodium is 23.0 grams per mole. 3 significant figures. So let's find chlorine on our periodic table now. It's towards the top right. Looking at my periodic table, its atomic mass is 35.4527. And so to 3 significant figures, the molar mass of chlorine is 35.5. And that's the number of grams in 1 mole of this element. Next up, find hydrogen. Hydrogen is in the very top left corner. It is the smallest of all atoms. Its atomic mass is 1.00794. When we round this to 3 significant figures, it becomes 1.01. That is the number of grams in 1 mole of hydrogen. Find oxygen on your periodic table. Periodic table says oxygen has an atomic mass of 15.9994. 4 to 3 significant figures, that rounds to 16.0. That's grams per mole. The periodic table is going to be very helpful for you as you go through this unit and units after this, especially because of these numbers. Now, there are some, like sodium and oxygen, that come up all the time. You're probably going to have them stick in your head just because you see it so much. But there are other ones, like maybe sulfur, that you'll need to look up because you won't have it memorized, but you'll need it at some point in time. A couple of other common ones: carbon, 12.0107, that rounds to 12.0 grams per mole. Nitrogen, 14.00674, 14.0 grams per mole.